Section 8.2 is titled Sequences and Equations. So for the objectives for this lesson, and remember you don't need to write this down, but we will discuss them again at the end of the video, we want to be able to describe sequences using words and phrases and be able to find terms in arithmetic sequences. So a few vocab terms here, please write these down. A sequence is just an ordered list of numbers. And a term is each number in the sequence. We have an arithmetic sequence when the difference between any two consecutive terms in the sequence is the same. And the common difference is what is that difference between the two terms in the sequence. So we're going to talk about a lot of these vocab terms as we go through some of these examples today. Again, please make sure you've written these down. So let's describe the sequence. We're told the sequence is 6, 7, 8, 9. Sometimes using a table is handy. The term number and the term, again, remember to keep these two straight. The term number is what's the first term in the sequence? Well, the first term is a 6. The second term is a 7. The third term is an 8. And the fourth term is a 9. In describing the sequence, we can say a handful of things. Some of you may be noticing that the difference of the term numbers is 1. And that will always be the case. But here we also notice that the difference in the terms themselves, or the common difference, is also 1. We're adding 1 to get to the next term. So the terms have a common difference of 1, but we also need to compare from the term number to the term. We can see that a term is 5 more than the term number. So if we were to write an equation that describes the sequence, or to find a specific term number, we're going to take, to find a specific term, we're going to take the term number, which is n, and we're going to add 5. So notice 1 plus 5 is 6, 2 plus 5 is 7, 3 plus 5 is 8, and 4 plus 5 is 9. So we can describe the sequence using words, and now we've also written an equation. Let's look at another example. Again, describe the sequence. Well, the first term is a 4, the second term number is 8, the third term number is 12, and the fourth term number is 16. So we still have the difference of the term numbers being 1. That's what we want. And you'll notice that the common difference is 4. We're adding 4 to get from one term to the next. So while the terms have a common difference of 4, the question is, how are we getting from the term number to the term itself? Well, you might say, well, from the first term number, 1, to 4, we add 3. That rule has to apply all the way down the table. 2 plus 3 is not 8. 3 plus 3 is not 12, and 4 plus 3 is not 16. So that's not going to be the rule for how to find a specific term. What we want to notice is that when you take the term number and you multiply it by 4, you then get the term. So 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12, 4 times 4 is 16. And we would write that the term is 4n. I like problems like this. They're almost like little puzzles where you're trying to play detective and figure out how can I get from the term number to the term, and it needs to be consistent all the way down the table. Here's another example where we have 10, 11, 12, and 13. So our first term is a 10. Our next term number is 11. Our third term number is 12, and our fourth term number is 13. So here again, we have addition of 1 from the term numbers, and that's how that will always work. But to get from one term to the next, we are also adding 1. In this example, it's very similar to example 1. When we have the term difference of 1 and a common difference of 1, we're essentially just adding 1 every time. But what we have to recognize is we didn't start with 1, because the first term is not 1, the first term is 10. How do we get from here to here? It looks like addition of 9. So let's check that all the way down. And we can see that that is in fact the case. So to get the term, we're going to take the term number and add 9, using words and equations to describe the sequence. Now let's look at an example where we need to describe the sequence using an equation, just like we've done in 1, 2, and 3, but then we also need to be able to find the 15th term of the sequence. You'll find that the equations come in very handy here. So we have 7, 10, 13, and 16. And I like to draw that little table again. You don't have to make it as fancy as they were in the first 3 examples, but basically your first term is a 7, your second term is 10, then we have our third is 13, and our fourth is 16. Now hopefully you can see these look to be additions of 3's every time. So we know that plus 3 is going to come into play here. We have a difference of the term number is always 1, from 1 to 2 to 3 to 4. We have a common difference of 3. So our common difference here, that plus 3, that's going to be our multiplier. So to find a term number, we do want to take 3 times n. But if we do 3 times 1, that just gives us 3. 3 times 2 just gives us 6. 3 times 3 just gives us 9, and 3 times 4 just gives us 12. So then we have to be adding something to get 7, 10, 13, and 16. So let's see what we might add. Well, 3 times 1 is 3, but to get to 7, we would add 4. So let's check if our rule works for the rest. 3 times 2 is 6, plus 4 is 10. 3 times 3 is 9, plus 4 is 13. 3 times 4 is 12, plus 4 is 16. So your term rule, or the equation, to find a term number, we take 3 times n plus 4. So we need to find the 15th term. So to find the 15th term, we're going to do 3 times 15 plus 4. 3 times 15 is 45. 45 plus 4 is 49. So the 15th term is 49. Now you could essentially continue on from 16, 19, 22, 25, 28, 31. You would eventually get to the 15th term, but you can see how writing the equation is much more handy. Imagine if someone asked you to find the 2000th term of the sequence. You certainly wouldn't want to continue adding 3 2,000 times to get to that term. Let's look at another example. We want an equation that describes the sequence 5, 8, 11, and 14. So the first is 5, the second is 8, the third is 11, and the fourth is 14. Notice we are adding 3, the common difference. Again, that's going to be our multiplier. So to find the term, we're going to take 3 times the term number, but then the question is, what do we add? Well, we have to check. 1 times 3 is 3, but how do we get from 3 to 5? We add 2. Let's check if that works. 2 times 3 is 6, plus 2 is 8. 3 times 3 is 9, plus 2 is 11. 4 times 3 is 12, plus 2 is 14. So if we're going to find the 20th term, 3 times 20 plus 2, so the 20th term of the sequence is 62. Again, you can see how writing the equation is very handy. So our objectives today were to describe sequences using words and phrases. That matches with examples 1 through 3. Please make sure you have full comprehension of those examples. You can rewatch the video if you don't, or ask questions in class. Also, can you find specific terms in an arithmetic sequence? Examples 4 and 5 show that. In class, we will work on worksheet 8-2.